Okay, here in podcast 11.3, we're talking about how acids and bases react together. And this is going to get filled out on page 10 of your packet. Let's get started with these neutralization reactions. These are reactions that happen when an acid and a base are mixed. They're opposites, so they cancel each other out or neutralize each other. Because they have opposite properties, those opposite properties kind of go away and cancel each other out as well. And what we're left with is always water, H2O, and some kind of salt. Now, you might ask yourself how we always make these things. Well, when we're mixing an acid and a base, here we're talking about an acid is something that starts with an H and a base ends with OH. The H plus from the acid and that OH from the base come together to make that H2O. And then whatever duff is left over is going to come together to make the salt. So this really is just about a special type of double replacement reaction. We've always done this before. We take the first thing from the first compound and the second thing from the second compound and put them together to make one of our products in this double replacement reaction. That's all that we're doing. It's just these should be even easier. We don't have to worry about much except writing the formula of this salt if we know we have a neutralization reaction. So just as a quick reminder, how do we write formulas? If we're writing an ionic compound, and these formulas we're asking you for are always going to be ionic, start by looking at the periodic table. Find those symbols, find those charges, and then if those charges don't cancel out, so if you have something like a +2 and a -1, sure, or a -2 and a +3, anything that doesn't cancel out like a +1 -1 or +2 -2 would, then that's when we cross-drop reduce. Now here's an example of cross-dropping and reducing that I'm going to explain as I do this, just to remind those of you who never quite got it that first time. When I say cross, I mean we're going to cross these charges that we found in step number 1. And these charges are literally crossing, switching elements going down to the bottom, and we usually do at the same time we drop the signs so that it's no longer a plus and a -2 and 4, it's just 2 and 4. After they've crossed and dropped. And then this last step doesn't always happen, but if possible, we need to reduce those subscripts. So because that 2 and that 4 down here could be divided by 2, they can be divided by the same number, we do that. 2 divided by 2 is 1, which we don't have to write, and 4 divided by 2 is 2. So that's our cross, drop, reduce. That's all we gotta do. Is if we see something like lead oxide, go find the symbols, find the charges, and cross-drop reduce. So, in these examples, what the key is going to be, because we know this is an acid-base reaction, is find those pieces, the acid and base pieces, the H and the OH, because we know those are always going to come together to form water. We can kind of get those out of the way, honestly. Just find them, cross them out, and then look at what's left over, and those pieces are going to be coming together to form our salt. Now, it is important that we remember whichever element was at the beginning of its formula originally needs to be at the beginning of this formula. So it's not ClCa, it's CaCl. Those are our symbols. The charges on the periodic table are a +2 and a -1, so because they don't cancel, we're going to cross-drop reduce. That ends up with a little 2 down there, and I'm actually going to make that red. Not too bad. Now our next one, lithium hydroxide and sulfuric acid, we take the H's and the OH's away, because we know those are going to make water. And then what's left over, lithium and sulfate. Lithium is first. If we check those charges, lithium's a +1, sulfate's a -2, so that sulfate's 2 is going to cross over onto lithium. Now, when it says magnesium hydroxide, we've got to write out this formula before we can find the formula of our products. So we've got magnesium and hydroxide. Second column, polyatomic, has a -1. So we cross drop reduce that over. Remember with polyatomics, we got to put those in parentheses. And then nitric acid is going to have nitrate with it because ic goes with 8. And that happens to be a +1 for the H and a -1 for the nitrate. So those actually do just cancel out. Now when we're moving things over, I'm going to kind of ignore that H and that OH that we already had here. So I'm going to be putting magnesium and nitrate together. Get rid of them. I don't want to cross those out. I worked so hard for those. So I know I'm making water, and then I'm putting whatever leftover pieces I have together, and that magnesium is still a +2, so it still cross drop reduces over there. Not a whole lot of reducing happens here, but when it does happen, it's important that you notice it and follow it. So these are our reactions. I do want you to go ahead and do this last one. Your packet says to do the balanced equation in addition to the overall and the net ionic, but all I need you to do is that first balanced equation, just like what we've been practicing. I already wrote out magnesium hydroxide for you in number 3. So hydrobromic acid is just going to be hydrogen and bromine. Go ahead and find those symbols, those charges, cross drop reduce. And then, of course, find your products, which you know is going to be water and some kind of salt. Just figure out what that salt is.